So for here is a bit review. So we have learned the first derivative test for the relative extreme values, right? So we said that, okay, if the slope of the function changes is sign, right? So if f prime x changes its sign from positive to negative, so it is called the maximum, right? And then if the f prime x changes from negative to positive, that it's a relative minimum, right? So here we know this is a first derivative test, right? But this test is a little bit time consuming, right? Because you have to calculate the neighborhood of both the left and the right part, and to plug in the two neighborhoods to the function to find out if I prime x changes the sign, right? So it takes a little bit of time. So here we know the second derivative. So we can use the second derivative test to find that, the same answer. Okay, here. So here we have the second derivative test for the relative extreme values, right? So it says that if the value of the first derivative of the function f at the point x0 is that f point x0 is 0. So that means that this is a stationary point, right? It's either a maximum or minimum or nothing, right? The value of the function at x0 is a relative maximum if the second derivative value is negative, or a relative minimum if the second derivative value is positive, right? Okay. So we can illustrate this by drawing the graph. So let's draw here. Suppose we have a relative maximum, right? So we know that at this point, x0, the first derivative at prime x is 0, right? So we said that it's a stationary point. So in the left neighborhood of x0, for example here, right, at this point, we know that for the function, it's an increasing function, right? So f prime is a positive number. But the function increases at a slower pace, right? If we draw another graph, so from this point to this point, the slope is always positive. So f prime is always positive. But the slope is becoming smaller and smaller, right? And when it reaches the function here, the point here, x0, the slope becomes 0, right? And then it changes sign to a negative number, right? So for the second derivative, at the point x0 here, because the slope of the function changes from a positive number in the left neighborhood to a negative number in the right neighborhood, right? Because you can think of this as a peak of the mountain. So here to the left, all the points are upward sloping, right? You are climbing the mountain. It's that upward sloping. And for all the points that's to the right of the x0 is downward sloping. So the slope of function changes from a very small positive number to the very small negative number from the left neighborhood of x0 to the right neighborhood of x0. So for f2 primes x at this point, right, f2 primes x is the change of the first derivative or the change of the slope. So this should be a negative number, right? Because from left to right, the slope decreases from a positive number to a negative number, So the second derivative should be negative at the point x0. So that's why we have a relative maximum if the second order at this point, if the second derivative at this point is negative. So similarly, we have a relative minimum if the second derivative at the point x0 is positive, right? So for example, again, this is x0. So for the left part of this curve of x0 is downward sloping. So f prime is a negative number. And to all the points that's to the right of x0, it becomes positive again, right? The slope becomes a positive number. So at x0 here, the slope is 0. So this means that the slope of the function changes from a negative number to a positive number from the left neighborhood of x0 to the right neighborhood of x0. So for the second derivative here, f2 primes x0 at the point x0 should be a positive number, right? Because the first derivative increases from negative to positive, right? So the second order should be a positive number. Sorry, the second derivative should be a positive number, right? So for a relative minimum, the second derivative at that point, at the stationary point, is a positive number. So this is how we use the second derivative to find out if it is a relative maximum or minimum. But if we find out, okay, the 2 primes, the second derivative is actually 0, then we cannot use this. Then we cannot use the second derivative test, right? So in this case, if we find that second derivative is 0, then we cannot use this test. So we have to use the first derivative test, right? Use the complicated one, right? So we cannot use this one. Okay, so let's see 2 examples. Find the relative extreme of the functions. So the first one, we have this quadratic function. So the first step is to find out the first and the second derivative, right? The first derivative is 8x minus 1, and the second derivative is a constant number, 8, which is a positive, right? So the second derivative is always positive, right? Because it's just a constant function, so it's always positive. So that means that this quadratic function should look like this. I look at this. The slope always increases. So first and the second, we need to find the stationary point. We let the first derivative to be 0. We find that the stationary point is 1/8. So here we have 1/8. And because the second derivative is a positive number along the curve, right, no matter which point you choose. So that means that at the point 1/8, the second derivative is a positive number. So based on the second derivative test, this should be the case B, right? So x star is a relative minimum based on the test. So for the second one, we have another function as cubed minus 3x squared plus 2. So again, the first step is to find the first and the second derivative functions. So the first derivative function is this, and second is the derivative of the first derivative. Right, so it should be 6x minus 6. So, and the second step is to find the stationary points. So we let g prime x be 0. So this is a quadratic function, and this is 0, so we know that this is a quadratic formula. Right, but here there's no constant term, so you don't need to use them. So we have two roots. The first one is 2 and the second one is 0. So we have two stationary points. We need to check that. We need to check them one by one, whether or not it's a maximum or minimum, right? So the way we check each of them is to plug in the stationary point to the second derivative function and to find out the sign of that, right? So g2 prime 2, we plug in the x1 star. So this should be 6 times 2 minus 6, right? So this is 2. Sorry, this is 6, which is a positive number. So from the second derivative test, if it's a positive number, that means that this should be a relative minimum, right? So g2, the value here is a relative minimum, right? It should be relative minimum and not absolute minimum. So for the g2 prime 0, it's negative 6, where you plug in the 0 to here, you find that it's negative 6. So it's a negative number. So g0 should be a relative maximum, right? So we've done with the second derivative test. But here's a little note, right? So here's a little note. So no matter you use the first derivative or the second derivative, what we have found is the relative minimum or relative maximum, right? It's a relative, not absolute. Right, the difference between these two is that, for example, I think we talked about that before, right? For a function like this, here we have a relative maximum right here, right, based on whatever test you make. But in the range of x, from x0 to x1, it's not the absolute maximum, right? It's not the maximum value along the domain from x0 to x1, right? The maximum number should be here, because this is where y gets the largest value, right, along the domain here. So although we have the relative maximum here and the relative minimum here, but we cannot say that the absolute maximum and absolute minimum. So we can know whether they are relative maximum or absolute maximum by comparing the stationary point and stationary point here to the endpoint here and endpoint here, right? So for this graph, we need to compare the 4 points. Right, so here we find the stationary points. So in this graph, we have 2 stationary points, but we also have 2 endpoints here, right? So any one of them can be a candidate for absolute minimum or absolute maximum, right? So when we find a relative maximum, we have to compare that to both the endpoints and to see if it's larger than both of them, to determine whether or not it's just a relative maximum or the absolute maximum, right? So if there's a question that asks you to find the absolute maximum along the domain from, for example, x0 to x1, right? So we have to find out the stationary points first. And then you determine whether this stationary point is a relative maximum or relative minimum by whatever test you take, right? The first derivative or second derivative test, right? And then you need to find the value of the function at the two endpoints here, right? Don't forget the two endpoints here. And then you compare the point here, the larger value of the endpoint here, to the relative maximum, made to determine which one is the absolute maximum, right? And which one is just a relative maximum, right? So just don't forget the endpoints when we find the absolute maximum in the domain, right, from x0 to x1. Okay.